A ladder of length 10 meters on horizontal ground rests against a vertical wall. The bottom of the ladder is moved away from the wall at a constant speed of 0.5 meters per second. Calculate the speed of descent of the top of the ladder when the bottom of the ladder is 4 meters away from the wall. So, this situation looks like this. A ladder, and this end moves with a constant speed of 0.5 meters per second. Let this distance be x and this distance be y, and we can see that there is a right angle triangle. And it is given that dx over dt is equal to 0.5 meters per second. It's positive because x is increasing and we need dy dt when x is 4. Dy dt is negative because y is decreasing and we need speed. Speed it's a positive value, so we need just consider the absolute value of the obtained result for dy dt. So, how to connect all variables and constants? Since there is a right angle triangle, we can write that x squared plus y squared is equal to 100. X changes with time, y also changes with time, but at any moment of time these two distances are linked by this formula. And we can just differentiate both sides and get, we can see x squared, x is the function of t, and if we differentiate with respect to t, we should apply a chain rule, and it becomes 2x dx dt plus 2y dy dt is 0. 100 is a constant, hence its derivative is 0, and we need just solve for dy dt. Dy dt is equal to negative 2x dx dt divided by 2y, which is negative x over y, multiplied by 0.5. dx dt it's a constant, and when x is 4, we can see that we need additionally the value of y at that moment of time. So when x is 4, to find y, we can use this formula. So 4 squared plus y squared is 100. So y is the square root of 84. Hence, dy dt is equal to negative 4 times 0.5 over the square root of 84, which is negative 0.218 meters per second, and hence the required speed is just the absolute value, so it's 0.218 meters per second. And that's all for this question.